So for my project, I decided to do pandas um, and show a little bit about what it does. So first, in the first few lines, I just have importing package and then import pandas as PD, as that's the common nomenclature that we use for it whenever we're importing uh, pandas. So Pandas is a data analysis software, and I needed some data in order to show off what Panda does pretty well. So this is data from 538, and the CSVs and the website I will link with the presentation that I submit to Canvas. But some info about the data set here is it shows competitor name, and it is from a candydata.csv, which is why there's chocolate, fruity, caramel, peanut, almondy, nougat, crisp, rice, wafer, hard, a bar, pluribus, and the main three here of sugar percent, price percent, and win percent. So in method one here, we're just reading the CSV using the .read CSV method, and we are taking the CSV file that we have here, which is the candydata.csv. We're passing it on to the read.csv method, and we're storing that into a data frame here, which is candy. Right, so that is just the read CSV method. It takes a CSV, or this is read underscore CSV, but there's also read underscore Excel, and a bunch of other ones that take whatever kind of document that you pass onto it and turns it into a data frame. So the next thing I have here that I want to show, which is already within the output that you can see here, is the head method, which prints out the overall structure of the data set and what it contains for the first 5 rows. You'll notice here that it says 0, 1, 2, 3, 4. Again, Python starts at 0, so it's taking us from the first value, which is 0, and the competitor name is 100 grand, which is the name of the candy. And if it contains chocolate, which it does, which is why they have a 1 listed here, and there's no fruit in 100 grand, which is why there's 0 here. And you'll notice here it states that there's 5 rows and 13 columns. Python will get rid of the ones that are taking up too much space here in the middle, which is why they have the ellipses, and shows the last 3 columns of sugar percent, price percent, and win percent. I know that sugar percent and price percent and win percent can be a little bit more confusing. However, this is sugar percent here is the percentile of sugar it falls under within the data set. Price percent is the unit price compared to the rest of the set. Win percent is the overall win percentage according to 269,000 matchups. And this is just the head method. It shows the overall structure and what it contains. So I also want to point out that longer data sets may have more columns. So you may have, like this is 13 columns, right? So there might be more columns that it omits if you have a larger data set. And with that being said, let me go to the describe method, right? So the describe method performs a bunch of summary statistics, right? And it gives you a lot of information about the data set, but you need to know context, right? So what does that mean? So here, within the data set, we know that according to our display at head, that it shows us if a candy is either chocolate or fruity or caramel. So these numbers here of mean, standard deviation, and min, they don't have any numerical value. Notice how 25% and 50% are all 0, right? For all 3 of them, right? Because it shows a Boolean value of 0 or 1. This is not a numerical value of 0 or 1. So even though chocolate has a 75% range of being 1, all of the maxes will always be 1 because it's always the value is either 0 or 1, right? Because it's Boolean. So the ones that have actual numerical value to it and have some sort of data that you can analyze here is the sugar percent of the candies, right? So here you can see that chocolate's mean is 47%. The mean within all of the candies is sugar percent is 47%. The standard deviation between all of the candies is 28%, right? And the min of all the candies is 0.011%. And the max of all of the candies of one candy in the whole data set is almost 98.8% sugar. I'm not going to go over the price percent, win percent values, but so that's what it means, right? So that's what I wrote here in this comment, that you need to know context in the data set. You need to know your data, right? Because some of this data, and this is why I always also chose this data set, is because you need to know your data in order to analyze it. And you can't just say, oh, chocolate has a mean value of 43. So 0.40, what does that mean, right? It doesn't have any statistical value. So I wanted to now, because I know that these type values are insignificant, the chocolate, fruity, or caramel, so I decided to print out the sugar percent into a new, easier to read. So this is sugar percent, right? As you can see, this table, which is the print statement here. And then I decided to print out this, which is here, right? Just for readability sakes. And you can also say in the describe method that it tells you the name of the column, right? I mean, we gave the name of the column, but it also tells you the type of the column. So within reading that also tells you the type. And we can see that it's float 64. So it's the same thing for price percent as well, float 64. And it is the same for win percent, which is also float 64, right? So now I want to combine the query and mean method and also an if statement into the last example. So you can't do, just by doing the query method, it's not good enough in order to do a comparison. So you need to also have a mean method, right? So what is the query method? So I'm querying all the candies in the data frame that are chocolate. So chocolate underscore candies is a new data frame that I've created by using the candy.query method here, where I'm searching for where chocolate is equal to 1. So I'm taking all of the values or all of the candies that have chocolate in them. Some way, somehow, they all have chocolate in them. And it's the same thing for the fruity candies, where it's the candy.query where fruity is equal to 1, where I'm now taking the fruity candy. So again, as you can see, this is 100 Grand, Almond Joy, Baby Ruth. So all these are the chocolate candies. As you can see, Hershey's is there as well. So this is giving me 37 rows. Now, for the fruity candies, now look, Airheads comes again, right? So now Mike and Ike, etc., etc. I'm going to scroll down. So this gives us 38 rows. However, notice here that within the fruity candies, chocolate is in a Tootsie Pop, right? So now, technically, if I could build onto this query, I've made a simple query for now, but Tootsie Pop is a duplicate between both datasets because it has chocolate and fruity. It's chocolate and fruity. So it has a 1 in both, right? So let me go scroll down here into the printing out both data frames, which I just showed you. So that's the printing chocolate fruit candies and print fruity candies, which I just showed you in the output. Now I'm comparing two sugar percentage using the built-in mean method, right? So now, again, I'm creating a new variable called chocolate percentage, and I'm saying the chocolate candies data frame, I'm looking for the sugar percent column, and I'm taking the mean of that, right? I'm taking the mean of the chocolate candies sugar percentage, right? So I'm taking the mean of all the values. So this is where Pandas is amazing, because I just showed you that almost 38 rows data from which I did not even need to use a for loop in order to calculate the mean. I didn't need to sum up a score. I just did dot mean, and that was it, right? And it's the same thing for fruity candies or fruit percent, right? Where I just do dot mean and I'm looking for the fruit percentage. So it's the same thing for both of them, right? So again, now in the if statement here, I said if the chocolate percent, so if the chocolate percent or sugar percentage of the is greater than the sugar percent, so the average percentage of chocolate candies is 0.5111999, right? While fruit candies are lower at 46. Else, it would print out the percentage of fruit candies is that. However, because chocolate candies is higher, it prints out the first statement. So there you go. That's Pandas for you. And I hope you enjoyed learning a little bit more about what Pandas does and its usage. Thank you.